Hey Pre-Calc, in this video I'm going to be teaching you section 5 for the sum and difference identities and how to use them. So let's start with the sum identities. I recommend writing these in your notebook, but also writing them on a note card so that you have easy access to them. So there's 3 identities, one's for cosine, one's for sine, and one's for tangent. And it's cosine of alpha plus beta, just representing angles, equals cosine of alpha, first angle, times cosine of beta, minus sine of alpha times sine of beta. For sine, they're all set up the same way, so sine of alpha, we're adding 2 angles, and then I'll just do tangent down here too. Okay, so for sine, it's sine of your first angle times cosine of your second angle plus cosine of your first angle, sine of your second angle. And for tangent, it's going to be tangent of your first angle plus tangent of the second angle divided by 1 minus tangent of the first angle times tangent of the second angle. Alright, so those are your 3 sum identities. Your difference identities, again, there are 3. So we have one for cosine of the difference of 2 angles, sine of the difference of 2 angles, and tangent, difference of 2 angles. So for cosine, if you're subtracting 2 different angles, you can rewrite it as cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. For sine, it's going to be sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. And for tangent, it's going to be tangent of the first angle minus tangent of the second angle divided by 1 plus tangent of the first angle times tangent of the second angle. You'll notice the two, like the sum and the difference, are incredibly similar, right? It's just like the opposite, really. So these are 6 identities that you need to know. So let's talk about how to use them. So we're just going to do a couple examples in this video. Let's start with degrees. Students tend to do a better job with degrees. You do need to know your unit circle and all the angles on it well. So sine of 15 degrees, right? This is not on the unit circle. So what we can do to determine what sine of 15 degrees is write 15 degrees as the sum or difference of angles with unit circle values. Okay, so I know that sine of 15 is equivalent to, right, I could rewrite this instead of 15, say 45 degrees minus 30 degrees. right? So I'm doing the difference of two angles that I know on the unit circle. Then I'm going to apply my difference identity because it's the difference of two angles. So that'll be sine of my first angle times cosine of my second angle, 30, minus, because it's difference, cosine of the first angle, right? And then sine of the second angle. Now we're going to use what we know in the unit circle and rewrite this. So sine of 45, so remember we're thinking y value at 45 degrees, so that's root 2 over 2 times cosine of 30, so we're thinking x value at 30 degrees, which is root 3 over 2, minus cosine of 45 degrees, so root 2 over 2, and sine of 30 degrees, which in this case is 1/2. So now we're just going to simplify. So when we multiply radicals, remember you just do 2 times 3, and we multiply the denominators. And conveniently, they have a common denominator, so this isn't too much work. And I can rewrite this as the square root of 6 minus the square root of 2 over 4. And that's our final answer. So that's it for degrees. Now, radians is also a kind of problem that you guys will be getting, and that can be a little bit more challenging, especially if you don't know your unit circle. So let's do example 2. Right, and really, again, just like all the other problems we've been doing, practice is what's going to make perfect, right? So you need to practice this. So let's do tangent of 11 pi over 12. Right, so what's tricky is we need to think common denominators, right? 12's not on the unit circle, but 3 and 4 are, right, denominators, and 2, 6, right, pi over 6. So what two angles are going to add to be 11 pi over 12? Sometimes I recommend just doing some scrap work and figuring out, like pick an angle and kind of try to add with common denominators. So for this problem, we can add pi over 4 and 2 pi over 3. And then just like a little scrap work. So sometimes what I like to do, rusty especially, is like pick an angle to start with, so maybe pi over 4, and be like, okay, that with a denominator of 12 is 3 pi over 12. So what would I have to add to 3 pi over 12 to get 11? That would be 8 pi over 12. And that reduces to, not 4, to 2 pi over 3. So sometimes thinking of it in terms of denominators of 12 first can help you, and then you just need to make sure that the two angles you're choosing are on the unit circle. Alright, so that's probably the hardest part. Now we can use our identity. So because this is a sum, we're going to use the tangent sum identity. So that's tangent of your first angle, so tangent of pi over 4, plus tangent of your second angle, which is 2 pi over 3, divided by 1 minus tangent of your first angle, which is pi over 4, times tangent of your second angle, 2 pi over 3. Alright, now we use what we know in the unit circle. So tangent of pi over 4 is 1. And tangent of 2 pi over 3 is negative root 3. Okay. Then we have 1 minus, and tangent of pi over 4, like we said, is 1. I've put this in parentheses because we're multiplying by a negative. Okay. So now I'm just going to continue simplifying. So this is going to equal 1 minus the square root of 3 divided by, and then 1 times negative root 3 is negative root 3. And we'll distribute that negative 1, so this becomes 1 plus root 3. And we don't like to have radicals in the denominator, so that means we need to rationalize the denominator. So I'm going to multiply by the conjugate, which is 1 minus root 3 over 1 minus root 3. And make sure you distribute. So 1 times 1 is 1, and then we'll have 1 times negative root 3, and negative root 3 times 1, so it'll be negative 2 root 3. If I combine those together. Root 3 times root 3 will be the square root of 9, which is 3. 1 times 1 in the denominator is 1. And then I have plus and minus, and then the square root of 9. So this will be minus 3. So combining like terms, we have 1 plus 3, which is 4. 1 minus 3 is negative 2. And then we can simplify because 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is positive 1. And there we go. So radians is certainly harder. I'm going to recommend that you guys practice the radians a lot, especially in ALEX. And again, practice is what's going to make perfect. So try to not rely too heavily on your unit circle. Try to take those guesses. It's not going to be easy, but it will get easier.